this contraption with the what I like to call Frankenstein knife switches. They're not as big as what I really wanted, but they'll do the job.
David,
Yes.
Here we are. We have a lot of eye candy here and some things that look like suddenly we're back in 1857. What the heck is this?
Yeah.
And what are you guys all about?
That is a very insightful statement. This is exactly the point. This board is something that one of our sales guys built, and we were actually on our way to a show, and I was going to give a talk, and I thought, how can I demonstrate that, to a bunch of engineers, that this is really genuinely easy to use stuff and you can develop an application quickly. And I thought, well, if I can show them something that I've never seen before, I want somebody to hand me something out of the audience I've never seen before, and I'll, in the space of a few minutes here, maybe 15 minutes I thought in the presentation, I'm going to turn this into a product. So then I told one of the sales guys as we were driving, how about if you go to Home Depot or somewhere and get a piece of wood and get some knife switches. He actually went to Radio Shack for the knife switches. And I had one of our prototyping boards, and I gave it to him. And this board has all the I.O., basically it's just a breakout board for all the I.O. of our module. And it's got a little battery pack. So I said, glue all that stuff to a board, and I said, pick any I.O., any digital I.O. you want. I don't want to know what it is, but I want it to be a very obvious, nothing up my sleeves. There's just wires going to I.O.s. And basically ground the center one, and then you're going to either take one or the other of the pins to ground. Those are going to be my inputs. And I'm going to, you hand it to me, I'll have never seen it before, and I'm going to write the software to make that thing control this tank, this remote control tank that we've got. And this guy here is actually a sumo bot. It's a sumo wrestling robot, and it's a competition-ready weight and size Japanese mini sumo. So today we're kind of repeating what I did a few years ago, except with a new piece of hardware here. We're going to try to write a remote control, create a remote control so you can drive this guy. And so I want the left-hand knife switch to basically make the left-hand wheel go backwards and forwards, and the right-hand make the right-hand wheel go backwards and forwards.
The engineering audience I know is watching this with amazement because you had a sales guy actually did this.
Yeah, exactly. That's part of the coolness, If a sales guy can build the hardware, it's got to be pretty good. Well, if it works. So yeah, so let's get to the software, shall we?
Okay.
So I've got a script already loaded in there that knows how to PWM the motors and give us control of those wheels. And in that script, I've created a function called set motors. I'm going to start up our development environment called Portal. And again, this is the thing that you can download for free from our website. So in this case, I've got my Sumo bot that's already got code loaded in it. I can refresh, and I see that I've already got this little script. So for this particular remote control application, the only function we're going to use, and go back to our node info, is in this hardware I.O. thing directly. There's a function called set motors. So let's look at this other device here. Double click on it, I refresh it, and you can see there's nothing in here. There's no script at all loaded. This is our remote control device. We're basically packing everything down into a function call with some parameters. So the key elements are I can call any function I want to over the air, and I can put new functions into a device because I can program them over the air with new scripts.
So with this particular Synapse portal, the programming, the whole setup, the only time constraint is in how much you're going to code up, right? I mean, how complex you want to code your system.
Right. The big advantage here is making complex things simple. And with Python and with our over-the-air programming and the RPC model, we can make really, really sophisticated and complex distributed networks actually work. Imagine having a lot of devices spread throughout a building, and only when you really got into the beta testing of these devices do you really know some things you really need to fix. And there are things in the software. Well, if you have to bring out a JTAG probe and plug in and open up each one of these things, that would be really, really hard. So the speeding up the development cycle, it does a couple of things. It helps the developers, definitely, but it also greatly increases the quality of the product. because things that you just didn't have time, and at some point you've got to shoot the engineer, right? That's what they always say. And you don't have time to add that one extra thing or fix that one extra problem. And what we found is, when we get out in the field, we're just like anybody else. We've got a lot of times when we build a system with Python and using this embedded scripting model, we can have a lot less code and do it in a lot shorter amount of time. But when we deploy the system out to the field, there's things we didn't think about. There are pieces of the business logic that you didn't think about. And so to get out there and be able to, on a widespread network, actually change the code and deploy it out to all the devices without ever going and touching them, it's an amazing difference, and it really increases the quality level of what you're able to deliver. So now Dr. Frankenstein has successfully made a creature, and it's actually not going crazy in this case, amazingly enough. You can see you can take very easily in just a few minutes, and the entire code for this remote control fits on this one screen here. And we've done over-the-air programming, we've done over-the-air communication. We can easily gather there's a sensor that gives me, I can read an A to D and send back the battery voltage. It's monitoring its own battery voltage. All that stuff is very easy to add in. Communicating from this all the way back to a PC is also super easy. We've made a library called Snap Connect. It also runs on our little embedded gateway box that lets you, you can write a Visual Basic app, define functions, and have this little Frankenstein switch call a function in your Visual Basic app just that easy. It's very, very simple, just as we've shown with between two different embedded nodes. So I let you drive mine. You let me drive yours?
Yeah, absolutely.
Okay,
Absolutely.